Hello, ladies and gentlemen, and welcome once again to our virtual classroom. Today, we're going to be going over lesson number 47, I believe, but regardless, that's 27-1 and 26-1 and 26-2, which is a volume of cubes and rectangular prisms. Now, today, we're going to focus on the volume of cubes. Nevertheless, the process is actually exactly the same for cubes and for rectangular prisms. And so before we actually start talking about how do we calculate the volume of cubes and rectangular prisms, let's talk about volume. Volume, I'm sure, is a word you've heard before, usually having to do with audio or music, things like that. But that is obviously not what we're referring to here. In this case, ladies and gentlemen, volume refers to the amount of space inside of a three-dimensional figure. Think of a box. Think of a bottle. It's the amount of stuff that can fit inside something or the amount of space that it takes up. Even something like your phone, you may think, well, nothing fits inside my phone. We're talking about physically, not data, but it takes up a certain amount of space. Think about a book. When you have a book, the pages are taking up space. And so it's the amount of matter that can fit or is displaced or is inside of something, a three-dimensional figure. Now, what do I mean by three-dimensional figure? Well, if I can minimize this, a three-dimensional figure, well, let's consider a two-dimensional figure like a square or rectangle. Think of a circle or oval or something like a triangle. Ladies and gentlemen, these are all two-dimensional figures because they only work in two dimensions. They work in a horizontal dimension. They have a certain width, and they have a vertical dimension. They have a certain height. They have a certain height. Even as I make this oval or circle, notice how I'm starting off. Here is my horizontal dimension, and then I'm going to start going up and down, and that's giving it a height, right? And so as you can see, I can manipulate. I'm just going two directions, this way and this way. That's what makes it two-dimensional. But ladies and gentlemen, a three-dimensional figure like a cube will not only have height and will not only have a horizontal and a vertical dimension, it will also have a, let me see what color can I use for this. It will also have a depth. Let me show you what I mean by that. Get a little artistic here. It will also have a certain depth. There we go. So as you can see, this is a cube. This is a cube, and let me add another line right here. There we go. Now, there we go. Now, this is a cube, and a cube, ladies and gentlemen, as you can see, does not only have length going this way and a height going this way, but it also has a certain depth, and the depth is going inward, right? It is a totally different axis. It's not only an X and Y, but it also has a Z axis. That's what makes this three dimensions: one dimension, two dimensions, three dimensions. How wide something is, which is described here, how high something goes, and how deep it goes as well in all three of those dimensions. So yeah, that's what makes something a three-dimensional figure. So if we can go back to our notes, that's why the definition of volume is the amount of space inside of a three-dimensional figure, and that is measured in cubic units. We're literally measuring how many little cubes, like the one that we see here, how many little cubes, if you can see, fit inside of something. And that can be in centimeters, like these cubes. It can be in inches. It can be in feet, cubic feet. It can be in cubic meters, which are much bigger, etc. So that is what volume is. Now the question is, well, how do we calculate volume? It's super simple, ladies and gentlemen. You just multiply the length times the width, as we see here, length times width, and then times the height. And think about it, like a box like this one, very similar to the one that we see there on the notes. Whenever we are calculating the volume, when you say length times width, that is the formula for the area of a parallelogram, which is like the rectangle on the bottom. So in this shape that I've drawn here, if you notice, here we have a parallelogram on the bottom. It looks slanted, but that's just because it's the angle that we're looking at it. So it's like this, and there is it's inside, it's the bottom face. So if I do length times width, that gives me the base of this shape, the bottom of this shape, and then I'm going to multiply that base by a certain height, by how high that goes. All of this is going a certain distance upward, very similar to what I see here. So I multiply the base times the height, giving me a certain area, and then I'm going to take that and then go upward a certain amount to make this box. All right, so that's why we multiply the length. Let's pretend that this is that box that you see there. The length, which is going to be this, the width, that's giving me the bottom base, and then I'm going to multiply by a certain height, like what we see right here. And so that's why sometimes it's written as base, big B base, because it is the base of the shape, but that's just length times width times the height. Now you might say, well, Mr. Lugo, what if you hold it up like this? Well, it doesn't matter. Let's make this the base. Okay, if we were taking the volume of this shape right here, okay, the first way we're going to take the length, which is 3, you can see 1, 2, 3, times the width, 3, so 3 times 3 makes 9. Notice how that's 9 squares, but now I'm going to take those 9 squares and then go 1, 2. So that's 3 times 2. So that would make 3 times 3 is 9 times 2 is 18. That literally makes 18 cubes, 18 cubic centimeters. That is how I get this shape right here. So I did the base, 3 times 3, that's 9. That's the base, length times width, times the height. If I add another layer, notice that now I have a cube. A cube is a three-dimensional figure where all the sides measure exactly the same. Notice that it would be a very similar process. We start with the base, which is length times width, 3 times 3, which is 9, times height, another 3, so 3 times 3 is 9 squares, times 3 is 27 cubic centimeters, or 27 cubes fit inside of this shape. The base, which was the 3 times 3, times the height. And that is precisely how you get the volume of a cube, as we can see over here. We are just taking, for example, if we have a cube that has sides that are 2 inches, so that means that this is going to be 2 inches, this is going to be 2 inches, and this is going to be 2 inches, very similar to this cube right here. 2 times 2, which is 4, times 2, which is 8. So as we can see, this makes 8 cubes. 1, 2, 3, 4, 5, 6, 7, 8. So it would be 8 cubic centimeters, in this case, 8 cubic inches. And that, ladies and gentlemen, is precisely how you get the volume of a cube or a rectangular prism, which we'll talk a little bit more about later. You do get a little bit more of that here in the notes. But that's essentially it. Now, hopefully this was helpful to you. And with that in mind, I will see you next time.